All right. All right. Today we're talking about polynomials. Comes from two Greek words, poly and nomial, which means name or for our purposes. So polynomial is something with many terms. All right. There are a few different kinds of polynomials. Like, for example, you have the quadratic polynomial, which is x like x squared plus 6x plus 7 or something like that. Say f of x equals this. Now, there are a couple of rules that polynomials have. Otherwise, they're not polynomials. The first is the fact that all of the degree amounts have to be whole numbers. Well, what are whole numbers? Numbers that are either 0, 1, 2, 3, or 4. Can't have fractions, can't have negatives. So for example, if I said, hey, is this a polynomial? If I said f of x is equal to x minus to the negative 2 plus 3x minus 4x to the 1/4. Well, we would say this is not a polynomial because of this right here and this right here. Does that make sense? The x is fine. As a matter of fact, I could throw a 5 on there because basically the way I can think about this is basically 5x to the 0, which that's fine, right? I can have 0, but I can't have negatives and I can't have fractions. Those would not be polynomials. All right, so in the book we've got 1a. 1a asks if f of x equal to 3x plus 5x to the 9th. The question asks, is this a polynomial? And the answer is yes. Yes. And for part B, it asks if we have f of x is equal to, let's see, 5x 1/2 plus 4x cubed plus 2, is this a polynomial, yes or no? No. Because of the. Any questions? All right. So that's the first part. Next, we're going to look at different kinds of polynomials. All right. So the basic polynomials, so we'll say basic, you can write this down, basic polynomials. We're going to start off with f of x is equal to 0. So this is known as the 0 polynomial. Or the 0 function, you should say, actually. Functions. So the 0 function. Oops. That again. Actual line. We can kind of make a table here. We're going to talk about these things, graphs as well. So at least with you guys, it shouldn't be too hard because you already have a line paper. And its graph should look something like this. Basically, you're just on the x-axis. Does that make sense? F of x equals 0 just means you're on the x-axis.
Can you look straight up to the right? Like the window? Like it's hanging off.
But this part,
Like just drag the window over to the right. Like the projector is off on this side.
okay. Yeah, it's off on both of them. So let me try to, I guess, stay right in the, guess I'll try to stay right in the middle there. Oh man, that sucks.
I mean, it's the projector. It's not straight over here. But it's over here.
Do we need the screens?
That better?
Much better.
So that's our zero function. Then the next one we're going to talk about is, okay, so let's say that, so f of x is equal to, say, just some constant c. All right. Now, c is like, just like, for example, so an example of this would be like f of x equals 2, okay? But any constant c. Then what we would have here is this will be a constant function. So constant function, which would be something kind of like, something kind of like this, where it's not at 0, but it is just straight across. It's constant. It's not really going much anywhere. Does that make sense? Now what we want to do is we want to look at, okay, well, what if f of x, say, is equal to x? Well, we call these functions linear. Like, for example, these are lines also. However, these lines have slope. We've seen them quite a bit, right? They can have positive slopes, they can have negative slopes, they can be raised up or down, depending on what the y-intercept is. We know we've got that. So, for example, negative slope or positive slope, or it could be not centered, like near the origin or something like that. We know these are those linear functions. Everybody cool with that? These are all polynomial functions. Now we get into stuff that we talked about in this last unit, which were quadratic functions. This is like f of x equals x squared. That's the most basic. Obviously, they can get as fancy as something like negative 2x squared plus 5x plus 6 or something like that, right? And get real fancy. These are, like I said, these are the quadratic functions. And these first few we've been dealing with all year, right? The next few we've kind of seen, but we want to kind of establish them a little bit more now. But yeah, I just want to hit quadratic functions real quick. These are ones that look kind of like those basic parabolas, like sloping up, sloping down, or shifting around and stuff like that, change the vertex, stuff like that. Then come the two next types are power functions. These functions consist of stuff like f of x is equal to x to the nth power. And these are divided up into two types of power functions. Either you have an even, this is like x to the fourth, x to the sixth, and so on. You have odd, like x to the third, x to the 9th, and so on. You got two kind of types of power functions. We're going to talk about them separately. So we got evens, we got odds. When you have an even power function, it doesn't matter how high it goes. But even power functions, and we're going to actually apply some graphing just to show these, but your even functions, they're a lot like your quadratic functions. They're just kind of a little bit more square at the base, but very similar to your quadratic functions. Basically, they slope either upward on both sides or slope downward on both sides. Odd functions, on the other hand, are kind of weird. Odd functions have this thing going on where on one side, they're sloped down, or they're heading towards negative infinity this way. And then the other side, they're doing something completely opposite. It's kind of like a guy with his hands, like that. I don't know what he's doing, but like that. Whereas even functions are like, it's good. Kind of thing. Or stretching down and touching your toes. And those are the basic polynomials. Everybody cool with that? Questions? All right, so let's take a minute and see some of these things in action. So I'm going to go back here. So we got x squared. So let's start with the zero function. So if I say x equals 0, you can see once again it's a line that it's just the x-axis. Then if I do like something like 5 or any c, slider sleeps, depending on what c is, I'm going to go up, go down, all that good stuff. Then if I have something like x, these are linear. So if I have like some kind of ax or something like that, x plus c, it will just make it go either up or down, or slide around, or change things up, slope down, slope up. All of these are different things I can have with this linear function here. If I do x squared, so like if I do x squared, and this is what we've been working with. Let's see. X minus h, not 4, h plus k. And we move these things around, we can see, once again, let me zoom out here. But you can see they're getting narrower, getting wider, moving around. This is all the stuff we've been doing before, right? Everybody cool with that? Now, if we get into even and odd functions, right? So I'm gonna leave all these the way they are. Let's make this function odd. So x cubed, I'm gonna set everything equal to 0. And 8. This is the most basic type that you're gonna see of an odd function, right? And note, I can make this so it's a cube right now, and actually let me change the contrast because I can actually see it better that way. But it's cubed right now. If I make this to the 5th, or to the 7th, or to the 9th, y'all see how it's basically the exact same shape. If I can make it to the 11th, or 111th, or 1011th, it just becomes more kind of straight edgy. Does that make sense? But everything else still holds. The whole shifting left, shifting right, shifting up, shifting down, and switching sides and all that stuff still applies. Now, if I make this even, like 4 or 6 or 8, you can see once again it's like a parabola, basically. And I can still, I can stretch, I can still press, I can make things go under, I can move left, up and down, I can move left, right, I can do all that good stuff. Everybody cool with that? So those are the main ones that you need to know. All right. So now we're going to talk about some very important pieces of the polynomial. All right. So let's assume, let's say for a minute, that we have this polynomial right here. F of x equals x minus 2 x plus 5. You can write this one down. F of x equals x plus 5, x plus 1, x minus 2 squared, and x minus 5 cubed. So it looks something like this. Oops. Mess with this real quick. Look a little bit less. Okay, so there's some things that we want to do with this that we want to talk about. First thing we want to talk about is that this graph, though it looks really weird, is smooth and continuous. So like, for example, if I had, you don't have to write this one down, but I'm just saying, if you had f of x equal to x cubed plus 5x plus 6 or something like that, you can see that this graph is smooth and continuous. Continuous just means you can draw it without ever lifting your hand off the page. Does that make sense? So this has no breaks, it has no holes, it has no nothing. You can just draw it with one thing. For example, if you saw something like, I don't know, I added this in and threw something else. Do something else in there, switch it around, and did like. You can see that this function, is this function smooth? Well, yeah, it's smooth, but is it continuous? No. All right. Now, let's take a look at this function. What if you had f of x is equal to the absolute value of x? Is this function continuous? Well, yeah, it's continuous, but is it? You can't. If I let's but is this function smooth? No, because we got this point. Does that make sense? So we see that polynomial functions are smooth and they are clean. The next thing that we can say about these functions is that they've got pieces where they're above the x-axis, below the x-axis, where they cross versus where they touch. So let's take a look at that. When we're talking about crossing the x-axis, you can see that in this case, we've got here, we're going to cross the x-axis. Here we cross the x-axis. Here we say touch the x-axis. And here we cross. All right. So in other words, you see the difference between crossing and touching. Crossing just means that you were all, basically you were negative, and now you're positive. Then you went from positive to being negative. But here you were negative, you went up, you touched the x-axis, but you were still negative. Does that make sense? So that's the difference between touching the x-axis and crossing the x-axis. These points, so this is, you can write this down. Points where your function f of x is equal to 0 are called zeros. Really, that's something. In our problem, we can see that -5 is a place where we touch the x-axis. -1 is a place where we touch the x-axis. 2 is a place where we touch the x-axis. I'm sorry. Let's say -5 is where we cross the x-axis. -1 is where we cross. -2 is where we touch, and +5 is where we cross the x-axis. Right? These are all known. -5, -1, 2, and 5 are all known as zeros. Does that make sense? There's zeros of the polynomial. What does that mean? That means these are values which, if I input, I get out 0, just like with x squared, like with our. It's basically x-intercepts. Questions? So now, I want us to take a deeper look at this. This type of polynomial is what we call being factored. It's in factored form because you can see that these are all the factors of it. Okay, in other words, you have x plus something or x minus something. That would be a factor of your polynomial. Now, the factors and the zeros have a relationship. So for example, I've got x plus 5. If your factor is x plus 5, then your 0 is minus 5. Why is that the case? Why do you think that it is? Yeah, you change it. More probably, what happens if I put -5 in there? It makes 0. That's why it's called a 0. Does that make sense? So you see that this factor x plus 5 has to do with this 0, -5. Does that make sense? This factor x plus 1, the next one, has to do with this 0, negative. The next factor we have is x minus 2 squared, which is this one. No, if we isolate it for a minute and we look only at this part, what does this kind of look like? Just this part. What type of function does that look like? Starts with Q. Quadratic, y'all see that? Why is that? Because the 0 there is what? Also quadratic. Does everybody see that? So this 0, you can see it has, this 0 has basically a degree of 2, which is quadratic. So this is what we say is called a multiplicity of 2. So M2 is what we use. That's a multiplicity of 2. That last 0 we had was x minus 5 cubed. So when it crosses, what kind of function does it kind of look like here? Does it look like a linear one where it just crosses, or does it kind of slope up like a cube function? It looks like a cube function, or at least like an R function, correct? That's because it has a multiplicity of what? 3.
So would that be a power function?
Yes, it would be a power function. As a matter of fact, it would be an odd power function, right? So let's mess with this a little bit and see what happens. If I make this say 20, now it just looks like an even power function at 2 because it has a multiplicity of 20 as opposed to 2. Now it looks more like the quadratic. If I change this to be, instead of 30, make it 32. Well, what does that do? Now it's got a multiplicity of 32. It kind of looks like that. Does that make sense? Y'all see how the multiplicity works with the with the factor? So that's how those work. All right, so for number 2, it says f of x equals literally what we have up there. And we talk about the multiplicities, which I've already said. So here's how you would write that. Say the zeros, you can list them out, would be -5 with a multiplicity of 1. negative 1 with the multiplicity of 1, positive 2 with the multiplicity of 2, positive 5 with the multiplicity of 3. And then if you were to draw, like for example, if you were to try to draw this out, you could say, okay, I've got negative 5, we're at negative 1, 2, and 5. I know I'm going to go through this one, I'm going to bounce off of this one, and then I'm going to kind of go through this one like a cube root function. It should look something like that. That makes sense? And this is what we have. Yes? Correct. Very, very good. If it crosses, then we have an odd multiplicity. If it touches, then you have an even multiplicity. Does that make sense? So if it crosses, that means it's odd. If it touches, that means it's even. And it will ask you that. You can see the difference. Once again, here at 2, we have a multiplicity of 2, so it's going to touch. Here at 5, we have a multiplicity of 3, so it'll cross. Questions? I don't know. That?
Yeah.
All right, so here's the challenge for you. Number 3 says form. Actually, form a polynomial whose zeros are 3 with a multiplicity of 1, negative 4 with a multiplicity of 2, and then it's of degree. You can write it in factor form. Let me give you a couple, about 30 seconds or so. See if you can write that out. Okay. So for this one, what should that factor look like? X minus 3. Y. Right, exactly. And do I put any numbers up here or just kind of leave it? Y. Yeah, you can think about it, it's like an invisible 1 right there. Right? All right, so that's that one. Now we've got negative 4. So that you have X what? Plus 4 to the what power? 2. So my answer should be f of X equals x minus 3 and x plus. Questions?
When you say that it has a degree of 3, is that because it's 1 plus 2?
Yes.
Okay.
Very good. It has a degree of 3 because this is 1 basically, and then plus 2. If you were to multiply just the first terms, you'd have x in that first one, and then you'd have x squared for the second. So multiply those two together, you get x cubed. Now, let me take it a little bit further. At this 0, at 3 being the 0, will I cross the x-axis or touch? You have a question? Oh, sorry. No, you're fine. Would I cross the x-axis or touch the x-axis? Cross. Yes. At squared, would I cross or would I touch? Touch. Everybody cool with that? So let's prove. See, at -4, we touch, at 3, cross. Everybody cool with that? Any questions? Awesome. All right, I think this is a good place to take 5. So stretch your legs, do what you gotta do, use the restroom, walk around the room, get some blood rushing back to your brain. We'll come back in about 5 minutes, really. So about 5:57, we'll take these last 18 minutes, and we're gonna knock the rest of this stuff out. Just ask you to answer the question. Get it?
Make sure I get really big into fitness again. That way I can plan for long term. I should be able to add about another 10 years of comfort. Living. Doing gym.
One more minute, we're gonna get back to it.
Yes. Yeah. I would not be going, but I have my little pack. Set up downstairs. I just prioritize that. I will today. I will. There's stuff. I should. My grades reflect, sure.
One last shameless plug, just so that you know, you go under Zoom, under cloud recordings, it does exist, it's right here. However, it is kind of hard to tell what it is. You probably see a whole bunch of these pop up. So the best thing, the thing that I've done is under files, test review videos, and I'll put them in there. So that's another place to find it. Does that make sense? Just so it's a little bit easier to do so. You can go under Zoom, it is there under cloud recordings.
October 4th, right?
Yeah, this one right here. But like I said, I don't know how to change. I literally don't know. I tried. It won't let me change the name on that. So I said I just created a file. Go under test review videos, test 2 review. Am I cool with that? And I'll do that for each one. Of the ones that. Let me actually make sure. Yeah. Don't watch the full hour thing. Just get to the stuff you need. Just gotta make sure that you got everything that you need. All right, guys, let's knock this out. Rest of the stuff out. So number 4. Number 4 asks this. It says list all zeros. So we got f of x is equal to x squared times x minus 2. First thing that it says is list each zero in its multiplicity. So list zeros and multiplicity. And then determine whether it touches or crosses at each x-intercept. So there are 2 zeros here. First one is the first 0 is 0 itself. Why? Because if I plug 0 in here, then I get 0 out. Everybody cool with that? Where's the other 0 at? 2. 0 has a multiplicity of what with it? 2, and 2 has a multiplicity of. At 0, I'm going to cross or touch. Touch. At 1, I'm going to cross. Am I going to cross or touch? Cross. Y'all see how quick that was? And now I can actually plug in and see if I'm right, even though I know I'm right. And you can see here, it touches at 0 like you said it would. And crosses at 2 like you said. Everybody cool with that? Questions? All right. So now we're going to talk about turning points and behavior. So here's the key. Notice here I've got 2 zeros, right? 2 distinct zeros. And if you look at this function, it's got 2 turning points. Now, normally, but the question is, okay, what is the degree here? What's the degree? 3, because we have a multiplicity of 2 and a multiplicity of 1. If you add those together, you get 3. So check this out. If the degree is 3, but I've got 2 turning points. Okay.
Question right
Yeah.
there. I know it's going up and back down and back up. You don't count it back up. It's going back up.
So yeah, so from left to right, we start by going up. Then we go down. So that's 1 turning point. Then we go back up. That's 2 turning points.
Okay.
Yeah, this counts as 1 turning point. This counts as the other one. Their turning point is the same thing as a relative max or relative min. Is it a peak or a valley? Right? And they count. Now, let's say I've got something like, let's throw an x plus 3 in there. So now what is the degree of this polynomial? What's the degree? Degree is 4, right? How many turning points are there? 3. 1, 2, 3. Okay. What if I make this x minus 3 squared? Now how many, what's the degree of this polynomial? 5. 2 plus 1 plus 2 is 5. How many turning points are there? 4. 1, 2, 3, 4. So from this, what is the relationship between the degree and the turning points? Yes, absolutely correct. If your degree is, your degree, for example, is like 5, the amount of turning points you have, or the max amount of turning points you have, would be 4. It's 1 less than your degree.
So the turning point is 1 less than a degree.
Correct. In other words, if your degree is n, your turning points will be n minus 1. Any questions on that? All right. So that's turning points. Now we're going to talk about in behavior. Basically, we said this is an x to the 5th. This is a 5th degree polynomial, correct? Well, what if I had x to the 5th? If we zoom out, you'll notice that x to the 5th on the right, as x is getting closer to infinity. So in other words, we're going more in this direction. What's my y value doing for the purple? What's y value doing? Is it going up or is it going down? Up. And as x is approaching negative infinity, is it going up or is it going down? Down. These right here, this is what we call the end behavior. In other words, what's happening at either end of my function? Does that make sense? And like I said, remember how we drew all those basic functions together? That was for a reason. Because you just gotta memorize what they look like. X to the fifth, they're positive, and go up like that, and so on. So what if I put a negative in front of it? What if I did negative x to the fifth? What do you think would happen?
Switch it around.
They switch. Does that make sense? So because if I multiply all these together, this would be, let's see, x squared, you have x. And when I say multiply all together, I'm just talking about the first term. This will be x, but then x squared, so that'll be x to the fifth. Because this is the same as this, no, even though all kinds of wacky, weird things are going on with the crossing and the touching and all that stuff, essentially, notice that on either end is the exact same as my x to the fifth function. Does that make sense? So the basic function is the exact same as this one with all the weird stuff going on in it. Does that make sense? In other words, what we can say is the end behavior is the same as the parent function. Does that make sense? So on either side, I could automatically tell just by looking at the parent function, or I'm going to introduce a new word called the leading term. The leading term is just, if you put things in descending order, it's whatever's first. So for example, if I had f of x, you don't have to write this down, but I'm saying if I had f of x is equal to 2x squared minus 3x to the 7th, that would not be in descending order. Why? Because x to the 7th should go first. Does that make sense? You have a degree of 7. 7 is before 2. So it should be negative 3x to the 7th plus 2x squared. Now, from that, what is the degree on this polynomial? 7, right? It's the highest degree polynomial. So it will be 7 in this case. So if I was to graph this, the end behavior should be the exact same as if I did this. Does that make sense? So let's prove it. So if I do 2x squared minus 3x to the 7th, okay, and I plug in just negative 3x to the 7th, the end behavior, yes. The end behavior, as you can see, is same. Everybody cool with that? So that's why you gotta know if it's odd, even, you gotta know what those look like. All right. That's the behavior. Now, what you can also check is between values, what's happening? Am I going to be above or below the x-axis? So for example, let's say that we want to graph this function right here. So let's say, I'm just going to rewrite it. F of x is equal to x squared times x minus 2 times x plus 3 squared. And we want to graph this function. Okay. What we have to do is we have to, first, we can determine what the end behavior is going to be. So we do that by saying, okay, this is x squared and times x squared, so x to the 5th. So I already know that the end behavior is going to look something like this. Everybody cool with that? Then what you do is you look at your zeros. You say, okay, my zeros are going to be 0, they're going to be positive 2, and they're going to be negative 3. Everybody cool with that? So my zeros are going to be there. I know I'm going to have a multiplicity of 2 here, multiplicity of 2 here, and a multiplicity of 1 here. In other words, I'm going to touch, and cross. Everybody cool with that? So now what I do is I start with the end behavior on the left. I cross Well, no, I'm not gonna cross there. I should do what at 3? Should I cross or touch? Touch. So that means it's gonna do something like this, right? Then what's it gonna do at 0? Is it gonna cross or is it gonna touch? Touch, because it's multiples of 2. That's okay. And now I'm gonna do what? Cross. And notice the end behavior is matching. Everybody cool with that? So now let's plug in and see. So, everybody see how we did that? Start with the end behavior, then note multiplicity is even or odd, cross or touch from there. All right. Number 5, it asks for some graphs and stuff. All right, so now we're going to go into the intermediate value theorem. I know I've got 5 minutes, but I think I'm actually going to have time to finish this up. So let's go to the intermediate value theorem. Basically, the intermediate value theorem states if f is continuous, technically on the interval a, b, if f of a and f of b are opposite signs, then 0, or basically, then f has at least 1 0. What in the world does that mean? All it means is if you got this number line, right? And you got the points, say 2 and 5. And I tell you that, hey, f of 2 is 6 and f of 5 is -3. Well, then you can tell that in between 2 and 5, I had to cross the x-axis somewhere. Does that make sense? So if I said f of 2 is 6, that'll be like somewhere up here. If I said f of 5 is -3, it'll be somewhere down here. Well, how do I get from here to here? I have to do what? That makes sense? Somewhere in there, I've got to cross it. That's all this means. If your sign changes, that means at some point I had to cross 0 somewhere. All right, cool with that? All right, so let's look at number 6. Number 6 says use the intermediate value theorem to show that the polynomial has a 0 on the interval 0, 1. The polynomial is f of x is equal to 10 x to the 4th minus 4 x cubed plus 5x minus 1. So we're going to plug in 0. We want to look at the interval 0 to 1. So if I plug 0 in, I make that 0, 0, and 0. So f of 0 is -1. And if I plug 1 in, then I have, let's see, 10 minus 4 plus 5 minus 1, 6 plus 5 minus 1, so that'd be 10. So f of 0 is negative, f of 1 is positive. What does that tell me about, is there a 0 between 0 and 1? Yes, it has to cross somewhere. I don't know where, but it's got to cross somewhere. Does that make sense? That's the intermediate value. number 7. Solve graphically this thing. Oh, man, we're not coming. All right. I'm gonna stop it right there. Does it work?